Welcome back to Bilal Consultancy, your trusted source for expert insights on business and management topics. Today we're diving deep into a critical process in risk management: failure mode and effects analysis, commonly known as FMEA. Have you ever wondered how companies like SpaceX, Toyota, and Boeing consistently deliver reliable products and services, even in the most complex and high-stakes environments? The answer often lies in their effective use of FMEA. Stick around, because by the end of this video, you'll understand the fundamentals of FMEA and how it can benefit your organization too. What exactly is FMEA? FMEA is a structured approach for identifying and mitigating potential failure modes in a product, process, or system. It helps us anticipate and prevent problems before they occur, which can save businesses time, money, and their reputation. When to use FMEA? When a process, product, or service is being designed or redesigned. After quality function deployment, QFD. When an existing process, product, or service is being applied in a new way. Before developing control plans for a new or modified process. When improvement goals are planned for an existing process, product, or service. When analyzing failures of an existing process, product, or service. Periodically throughout the life of the process, product, or service. FMEA procedure. Note, this is a general procedure. Specific details may vary with standards of your organization or industry. Before undertaking an FMEA process, learn more about standards and specific methods in your organization and industry through other references and training. Assemble a cross-functional team of people with diverse knowledge about the process, product or service, and customer needs. Functions often included are design, manufacturing, quality, testing, reliability, maintenance, purchasing, and suppliers, sales, marketing, and customer service. Identify the scope of the FMEA. Is it for concept, system, design, process, or service? What are the boundaries? How detailed should we be? Use flowcharts to identify the scope and to make sure every team member understands it in detail. Fill in the identifying information at the top of your FMEA form. Figure 1 shows a typical format. The remaining steps ask for information that will go into the columns of the form. Identify the functions of your scope. Ask, what is the purpose of this system, design, process, or service? What do our customers expect it to do? Name it with a verb followed by a noun. Usually one will break the scope into separate subsystems, items, parts, assemblies, or process steps and identify the function of each. For each function, identify all the ways failure could happen. These are potential failure modes. If necessary, go back and rewrite the function with more detail to be sure the failure modes show a loss of that function. For each failure mode, identify all the consequences on the system, related systems, process, related processes, product, service, customer, or regulations. These are potential effects of failure. Ask, what does the customer experience because of this failure? What happens when this failure occurs? Determine how serious each effect is. This is the severity rating, or S. Severity is usually rated on a scale from 1 to 10, where 1 is insignificant and 10 is catastrophic. If a failure mode has more than one effect, write on the FMEA table only the highest severity rating for that failure mode. For each failure mode, determine all the potential root causes. Use tools classified as cause analysis tools, as well as the best knowledge and experience of the team. List all possible causes for each failure mode on the FMEA form. For each cause, determine the occurrence rating, or O. This rating estimates the probability of failure occurring for that reason during the lifetime of your scope. Occurrence is usually rated on a scale from 1 to 10, where 1 is extremely unlikely and 10 is inevitable. On the FMEA table, list the occurrence rating for each cause. For each cause, identify current process controls. These are tests, procedures or mechanisms that you now have in place to keep failures from reaching the customer. These controls might prevent the cause from happening, reduce the likelihood that it will happen, or detect failure after the cause has already happened but before the customer is affected. For each control, determine the detection rating, or D. This rating estimates how well the controls can detect either the cause or its failure mode after they have happened but before the customer is affected. Detection is usually rated on a scale from 1 to 10, where 1 means the control is absolutely certain to detect the problem and 10 means the control is certain not to detect the problem, or no control exists. On the FMEA table, list the detection rating for each cause. Optional for most industries. Ask, is this failure mode associated with a critical characteristic? Critical characteristics are measurements or indicators that reflect safety or compliance with government regulations and need special controls. If so, a column labeled Classification receives A, Y, or N to show whether special controls are needed. Usually, critical characteristics have a severity of 9 or 10 and occurrence and detection ratings above 3. Calculate the risk priority number, or RPN, which equals S times O times D. Also calculate criticality by multiplying severity by occurrence. S times O. These numbers provide guidance for ranking potential failures in the order they should be addressed. Identify recommended actions. These actions may be design or process changes to lower severity or occurrence. They may be additional controls to improve detection. Also note who is responsible for the actions and target completion dates. As actions are completed, note results and the date on the FMEA form. Also, note new S, O, or D ratings and new RPNs. Key elements. FMEA is composed of 3 main elements. Failure modes are the ways in which a system or process can fail. They can be classified into 4 main types. Functional failures. The system or process fails to perform its intended function. Degraded function failures. The system or process performs its intended function, but at a reduced level of performance. Intermittent failures. The system or process works intermittently, sometimes failing and sometimes working normally. Catastrophic failures. The system or process fails completely and irreversibly. Effects are the consequences or results of a failure mode. They can be classified into 3 main types. Customer effects. The failure mode affects the customer in some way, such as causing dissatisfaction, inconvenience, or financial loss. Internal effects. The failure mode affects the organization's internal operations, such as causing delays, rework, or scrap. Safety effects. The failure mode could pose a safety hazard to people or the environment. Severity ratings are numerical values assigned to each failure mode to assess the seriousness of its effects. Severity ratings are typically on a scale of 1 to 10, with 10 being the most severe. Occurrence ratings are numerical values assigned to each failure mode to assess the likelihood of it occurring. Occurrence ratings are typically on a scale of 1 to 10, with 10 being the most likely to occur. Detection ratings are numerical values assigned to each failure mode to assess the likelihood of it being detected before it causes any adverse effects. Detection ratings are typically on a scale of 1 to 10, with 10 being the most difficult to detect. RPN, risk priority number, is a calculated value that is used to prioritize failure modes for corrective action. RPN is calculated by multiplying the severity, occurrence, and detection ratings for a given failure mode. The higher the RPN, the higher the priority for corrective action. Here is an example of how to use failure modes, effects, and severity, occurrence, and detection ratings. System. A car engine. Failure mode. The engine overheats. Effects. Customer effects. The car stalls, leaving the customer stranded on the side of the road. Internal effects. The engine damage may be costly to repair. Safety effects. The overheating engine could cause a fire. Severity rating, 9, catastrophic. Occurrence rating, 5, moderate. Detection rating, 7, difficult. RPN, 315. This RPN indicates that the engine overheating failure mode is a high priority for corrective action. The organization may want to consider implementing preventive measures, such as installing a temperature sensor that will turn off the engine before it overheats. Failure modes, effects, and severity, occurrence, and detection ratings are a valuable tool for identifying and prioritizing potential failures in systems and processes. By understanding these concepts, organizations can take steps to mitigate risks and improve the quality and reliability of their products and services. Process. Identify the process or system. The first step in the FMEA process is to identify the process or system that you want to analyze. This could be a manufacturing process, a software development process, or even a customer service process. The scope of the FMEA should be clearly defined so that the team can focus on the most important areas. Gather a cross-functional team. It is important to assemble a cross-functional team to conduct the FMEA. The team should include people with expertise in all aspects of the process or system being analyzed. This will help to ensure that all potential failure modes are identified and evaluated. Identify failure modes. Once the team has been assembled, the next step is to identify all of the potential failure modes for the process or system. This can be done by brainstorming, using process flowcharts, or reviewing historical data. It is important to be as comprehensive as possible in identifying failure modes. Assign severity ratings. Once the failure modes have been identified, the team needs to assign a severity rating to each one. The severity rating is a measure of the impact that the failure mode would have on the customer or the organization. Severity ratings are typically on a scale of 1 to 10, with 1 being the least severe and 10 being the most severe. Assess occurrence. The next step is to assess the likelihood of each failure mode occurring. The occurrence rating is a measure of how often the failure mode is likely to happen. Occurrence ratings are typically on a scale of 1 to 10, with 1 being the least likely to occur and 10 being the most likely to occur. Determine detection. The final step is to determine how easy or difficult it is to detect each failure mode before it reaches the customer or the final product. The detection rating is a measure of how likely it is that the failure mode will be caught before it causes any problems. Detection ratings are typically on a scale of 1 to 10, with 1 being the easiest to detect and 10 being the most difficult to detect. Calculate risk priority numbers, RPN. Once the severity, occurrence, and detection ratings have been assigned, the team can calculate the risk priority number, RPN, for each failure mode. The RPN is calculated by multiplying the 3 ratings together. A higher RPN indicates a higher priority for corrective action. Prioritize actions. The next step is to prioritize the failure modes based on their RPNs. The team should focus on the highest RPNs and prioritize their actions for mitigation. Implement and monitor. Once the failure modes have been prioritized, the team needs to develop and implement corrective actions to reduce the risk. The team should also monitor the process or system to ensure that the corrective actions are effective. Here are some additional tips for conducting an effective FMEA. Be specific when identifying failure modes. Use realistic and objective ratings for severity, occurrence, and detection. Consider all potential effects of each failure mode, including customer effects, internal effects, and safety effects. Document the FMEA results so that they can be used to improve the process or system over time. FMEA is a valuable tool for identifying and prioritizing potential failures in systems and processes. By following the steps outlined above, organizations can use FMEA to improve the quality and reliability of their products and services. Example: system, bakery. Failure mode, power outage. Effects: customer effects, missed customer orders, dissatisfied customers, damage to reputation. Internal effects: spoiled ingredients, lost revenue, reduced productivity. Safety effects: none. Severity rating: 8, high. Occurrence rating: 5, moderate. Detection rating: 6, moderate. RPN: 240. This RPN indicates that a power outage is a high-priority failure mode for the bakery. The bakery could take a number of steps to mitigate this risk, such as installing a backup generator, connecting to a more reliable power grid, investing in surge protectors and other electrical safety equipment, having a plan in place for dealing with power outages, such as evacuating the bakery and storing perishable items in a safe place. By proactively addressing this failure mode, the bakery can reduce the risk of missed customer orders, spoiled ingredients, and lost revenue. Here is another example. System, bakery. Failure mode, incorrect ingredient measurement. Effects: customer effects, cakes and pastries that are too sweet, too salty, or otherwise not to the customer's liking. Internal effects: wasted ingredients, lost revenue, negative feedback from customers. Safety effects: none. Severity rating, 6, medium. Occurrence rating, 3, low. Detection rating, 7, difficult. RPN, 126. This RPN indicates that incorrect ingredient measurement is a medium priority failure mode for the bakery. The bakery could take a number of steps to mitigate this risk, such as using standardized measuring cups and spoons, training employees on proper ingredient measurement techniques, implementing quality control procedures to check ingredient measurements before they are used in baking. By proactively addressing this failure mode, the bakery can improve the quality and consistency of its products and reduce the risk of customer dissatisfaction. Conclusion. In conclusion, FMEA is a powerful tool for identifying and mitigating potential risks in your processes, products, or systems. By systematically analyzing failure modes and their consequences, you can make informed decisions to improve quality, reliability, and customer satisfaction. If you found this video helpful, please give it a thumbs up and subscribe to Bilal Consultancy for more insightful content. Have questions or need help implementing FMEA in your organization? Feel free to leave a comment below, and I'll be happy to assist. Thanks for watching, and I'll see you in the next video.